Hi all. Today we'll understand maximum power transfer theorem. Let us go through the definition of it. To obtain the maximum power from a network, the resistance of the load must be equal to the Thevenin's resistance of the network. Okay. For DC circuit, load resistance should be equal to Thevenin's resistance. So, what is the meaning of that? This is a circuit, right? This is a linear circuit, as we all know this. There is no involving if you write v naught, it will be in equation for straight line. Okay, so here what is the value of RL? RL is undefined, right? Like if it is there also, maximum power transfer theorem states that if you calculate the RTH value for this, we all know that this circuit can be represented using VTH, RTH and RL, right? So what is the value of RL so that the power transfer to this load becomes maximum? Okay, so that is what the meaning of this statement. Okay, so if you calculate RTH and VTH, and if your load is same as the value of RTH, then the maximum transfer to this load becomes maximum. Okay, that is what power transfer, maximum power transfer theorem states. Okay, what is the value of RTH? If you replace your RL same as your RTH, then the power transfer to this load will become maximum. Okay, so for that, what you have to calculate? We know this this can be done using Norton's theorem, right? So we can calculate RTH and VTH. Okay, so we will calculate RTH. You will just short circuit this voltage source. If it is a current source, you will just remove it. Okay, so what is the value of RAB? Like if this is terminal A and this is terminal B, what is the effective resistance across this these two terminals? RTH is equals to RL. So these two are in parallel. So 12 parallel with 24, and resultant is series with 17 ohm. So plus 70. So how will you calculate 12 parallel with 24? 12 into 24 divided by 12 plus 24 plus 17, you will get 25 ohm. So this is RTH, right? So this is the value of RTH. So we found out RTH. Now we have to calculate VTH. How will you calculate VTH? You will just remove this one, right? You will just remove the load resistance and calculate the voltage drop across that terminal. Okay, AB, if you consider this as AB. Okay, so now we all know that this is the circuit to calculate VTH, and we all know that there is no flow of current because this is open circuited. So we can, what is the voltage drop at this point is same as the voltage drop at this point. So how will you calculate VC? We can apply voltage divider rule, right? So 18 volts is there, 12 ohm and 24 ohm are in series. Since this is there is no flow of current in here, so this is simply a series. All the current coming here will flow through this resistance. So there is no need of considering this resistance. So we can directly apply voltage divider. VC equals to 18 into 24 divided by 12 plus 24. Okay, so if you calculate, you will get VC as 12 volts. So what is VC? VC is nothing but voltage drop across these two terminals, that is your VTH, right? So VTH is 12 volts, RTH is 25 ohms that we have calculated from here, and now you have to replace your RL same as your RTH. Okay, so that your maximum power transfer to this load becomes maximum. So what is power transfer? What is the formula for power? VI, right? So in this case, VL into IL. VL is the voltage drop across your load resistor. So VL into IL. So VL is I will calculate VL. This is 12 volts, right? They are of equal resistance. So 6 volts and 6 volts equally dividing. Okay, if you want, you can apply KVL or KCL. We can find out. VL is 6, and what is the value of IL? I is equals to V by R, 12 by 50. So 25 plus 25 is 50. So 12 volts is the input voltage, and R is 25 plus 25. You will get IL, value of IL So we PL is equals to 6 into 12 by 50, which is 1.44. Now if you change this value, sorry, I have mentioned, that is okay, like this is a voltage drop, sorry, this is ohm, okay, 25 ohm, I have written volts here. So if you change this value 25 ohms to any other value, the power drop across this will decreases. Okay, if you can decrease also, you can put 20 ohm resistor, or you can also increase to 30 ohm resistors, and you can calculate the power transfer to the load. In that cases you will get decreased power drop than this. Okay, 1.44 you will get other than 1.44, that is less than 1.44 watts. Okay, so what we can conclude, you will get lesser power transfer if you use RL other than RTH. So if you use other than 25 ohm load resistance, you will get only lesser power transfer. Okay, you can try with that. Okay, change the value of this resistance and calculate what is the power. You will get less than 1.44. That is what is the maximum power transfer. So I hope there is no need of simulation part for this. You can directly simulate. Okay, what you can do, just change the value of this RL other than 25, draw the same circuit. Okay, draw the same circuit and replace this RL other than 25 ohm. Find out what is the power transfer. Power transfer in the sense, measure the VL and IL and calculate the power. Okay, and change this resistance value and check out whether you get lesser than this one. Okay, thank you.